Good morning, friends. This is Durga from ITversity. As you guys know, this is backup for my live audience. So if I could not answer immediately on YouTube, bear with us. That being said, we'll start the session in a moment. Those who are on WebEx Live, please confirm that you guys can hear me and you can see my screen so that I can get started. Okay, thank you. So today we will again review the development lifecycle and also the execution lifecycle. I will take the same example, which is word count, which we have developed earlier. And irrespective of the uh, uh, business requirement, you have to implement using the similar approach. Okay, so I'm launching IntelliJ here.
Building a web.
I just want to confirm that it is being streamed to YouTube without any issues. Yeah, it looks good. So IntelliJ is up. So in our case, the problem statement for this is word count. To begin with, you should use uh, the Scala REPL to come up with the code snippet. And then you can actually include all these features of externalizing the parameters. You need to identify what all parameters that needs to be externalized, and you have to use the typesafe config or any third-party plugin or your own code to load these externalized properties so that we can control the behavior of our application as well as the execution of our application when it is submitted on the cluster. So we use typesafe config, which is third-party plugin to load the application properties. And one of the primary property which we are passing through application.properties is the execution mode. In dev, I want to run it in local mode. If I submit the same job as prod, I have to run in the yarn mode. That is one property which I'm using to control the behavior of execution when the job is submitted. On top of that, there will be a number of properties for dev and prod. You need to identify all these properties and put these things as part of the application.properties. And then when it comes to word count, first we need to identify what is the input file system and what is the input file format. So in local mode, we will read the local files. In yarn mode, we will read the HDFS path. If you want to read data from S3 or Azure Blob, you need to set a few additional properties such as access key and secret key for S3, Amazon S3 or Azure Blob. So you need to understand the impact of using different file systems as part of your program. In our case, we are using local file system for local and HDFS file system when we actually run it in the production. As it is default, we don't need to do anything additional exclusively. We just need to pass the input and output path as arguments when it is submitted on the cluster. But if you want to use different file system, you have to first use set additional properties. And then before actually processing the data, I want to pass the input path and output path as arguments. Hence, I'm reading input path and output path using args. Okay. Once the input path and output path is read as string, I want to validate whether it exists or not. For that, I'm using HDFS APIs. So this is how we actually create the file system object using file system.get of sc.hadoop configuration. And file system is a class under this package, arg.apache.hadoop.fs. Okay, so using this fs, we can perform several validations whether the input path exists. If you want to apply filters on files on the path, you can, I think there is a class called path filter. and you can even pass expressions and all those things. So you can play with these APIs, and you can make your program as sophisticated as possible in dealing with the paths. Okay, and then comes the processing of the data. So first we need to create the Spark context, and for that we need to have the configuration object. Once the configuration object is created, we have created the Spark context, and using Spark context, we can read the data from file system. Depending upon the file format you want to use, we can use different APIs. As in our case, we are using text data. I have given sc.text file as the function to read data from the input path. And then the functionality is to convert the line into records, tag them into tuples with one, and then use reduce by key to add those. After aggregating, before saving into the file system, I want to convert into the format I want to save. So in this case, instead of saving as tuples after applying reduce by key, I want to save it as a tab delimited string. If it is comma separated, you just have to put comma here. If it is column separated, you can put column. So depending upon the file for the data structure as part of the output files, you have to apply that logic as part of the map function after reduce by key. And then depending upon the type of file system you want to save, you can use the appropriate API. We have save as text file, we have save as object file, save as sequence file, and save as Hadoop file, as well as save as new API Hadoop file. So you have to use one of these things to actually save the data into different file formats. Okay, so this is the development life cycle, and sometimes we might have to have multiple actions um, before finally saving it to the file system, and each action will actually result in a job when we submit it. So that is called as chained jobs. So in this case, as part of this word count application, when we run this, as there is only one action, there will be only one job that will be executed on the cluster. Once this is done, okay, what you can do is you can actually go to the path here. You can right click on this. Okay, before actually building into the jar file, you have to validate. In this case, this program expects three parameters. One is the input path, second one is the output path, and third one is the argument to tell which execution mode you want to run, whether it is dev or prod, etc. And to pass those, you have to go to run edit configurations and make sure you have you have a configuration with the name of your with your class which you are trying to run. In this case, sparkdemo.wordCount, and then you can actually put the arguments here. So you can see these are space separated. This was the input path, and then output path. And then the execution mode. Okay, and then you need to make sure that the working directory is your working directory where you have this whatever project you are running on, and the class path has to be set. Then only it will work. And then click on OK, and you just right click on it, run word count, and it will be validated. And then you need to build the jar file. You can right click on this, copy path, go to the command line, cd paste the path, and here you will find the build.sbt. Wherever you have build.sbt, you have to run sbt package to build the jar file. And then the jar file will be created under this location, target Scala -2.10, and then this is the jar file. Okay, you just have to copy this jar file to the cluster on which you want to deploy. Okay, and also on top of it, you can run sbt console. So using sbt console, there is the advantage. that you can actually access these programs from the command line. I haven't covered this as part of the last session, so I'm covering this. I covered earlier when I actually talk about SBT console quite a bit extensively. Now we will put it into the use. Okay, so you can actually import Spark demo package like this. Okay, and then you can actually use the program name, which is word count, and main function you can invoke like this directly with the object name dot main, and it takes. Oh, is it frozen? Yeah, word count dot main. Oh, then it is WebEx issue because I am in wired network today. Okay, I have to raise this issue to WebEx. Meanwhile, I'm also working on Amazon Chime. So probably if you see a lot of glitches today, we will switch to Amazon Chime either, yeah, by next class, we will switch to Amazon Chime. I was under impression that it was wireless issue, but I think it seemed to be the issue with WebEx itself. It's very unfortunate. I'm paying almost $80 per month, uh, and it's causing these kinds of problems. Anyway, so here we need to, if you look into this, what the main function will take, it takes array of string as parameters. So what we have to do, so there is a question here about recording. Yeah, there is recording feature in Amazon Chime also. So we will see. We will do a try run before we actually decide to go with Amazon Chime. But I have already validated. Oh, I will not be closing WebEx immediately, so don't worry about that. You will have those, and as a backup plan, you have the videos in YouTube. If you want, I can actually put them in S3 and I can give the access so that you can download it. Okay, but the files are in WebEx. We will see how we can take care of this issue. And remember that these videos will not be permanent in WebEx. Okay, in YouTube, they will be permanent because WebEx, they give only 10 GB space. If I saturate that, I have to delete the old files. Hence, WebEx, I might not be able to manage forever. Whereas on YouTube, you will get these videos whenever you want. They will be there permanently. Okay, so anyway, here we can actually pass the input path, output path, and the execution mode like this. Users, IT university, research, data, code count.txt, and the output path, and then dev, something like that. Okay, and then you can run. So it will actually execute as the program within the SBT console. And on top of it, I'm killing this session. On top of it, you can also run it in standalone mode by using Spark Submit from here. You don't need to copy it to the cluster and then run the Spark Submit. You can also say Spark Submit, Spark Demo, sorry, class, Spark Demo, dot word count, master. Okay, we don't need to specify this. It's already taken care as part of the program. I can directly give the path like this. Okay, and it takes 3 parameters. One is this one, the input path. And second one is port count, the directory where I want to save the output, and then I want to run it in the dev mode, and I can run like this. You see, the program is running on your local PC itself. That's why I have emphasized to set up Spark on your local PC. You can actually run it even in the standalone mode. For the standalone mode, you need to do a bit of extra stuff. I will leave an exercise to you. You figure out how to run in standalone mode, local to your machine. So you can actually perform integration kind of testing using your PC itself, as long as you have Spark set up on your PC. Once this is done, we actually copy the file to the cluster using this command. And then we have to connect to the cluster. And then we can actually run the Spark submit command. Okay, let me put it in multiple lines so that it is readable to you guys. Okay, so I hope this is a bit better. So we give the class name. By default, if you don't give these three things, the default one will be number of executors will be 2, and executor memory will be 1 GB, and there will be only one executor core for um, executor, which means that only one task can be executed by a executor at any point in time. If you try to process 30 GB worth of data, it creates almost 270 tasks to process the data. And if you have only 2 tasks to run at any time simultaneously, it will take forever. It will take very long time to finish. For that reason, we need to understand the capacity of the cluster, and we have to play with these properties to improvise the performance of the cluster. So here, a few people have asked me to explain these 3 properties once again. So I'm taking care of that. It will take probably another 5 minutes to 10 minutes. So please listen carefully. If you go to the Ambari, so the place where you need to start is Ambari, or you can also start with the resource manager web interface. Resource manager web interface will be running on this IP address, and this is the port number. If you are not sure if you have access to the Ambari, you can also get to resource manager web interface through Yarn. You can click on Yarn and you can see the quick links here. You can see the resource manager UI here. That will take you to this page. And you can see the memory total and vCores. So vCores total. Okay. So we have 120 GB memory and 30 virtual cores. Maximum we can run 30 parallel tasks at any point in time in the cluster. We cannot go beyond that. There is a multiplier to that. I think if we give 30, it can go up to 60. But once you start giving more than 30, there can be some contention for the resources and the performance might be a bit down. Okay, so this is the, you can consider these as soft limits, 120 GB memory and 30, actually 120 GB memory is the hard limit and 30 cores is the soft limit. Okay. And then you need to understand few more configurations. Yes, so whatever you see as part of yarn, they are from yarn site.xml. If I click on configs, whatever properties you see here, it's nothing but readable version of yarn site.xml. And you can actually get the details about the property by just hovering onto these properties. So the property for the node manager memory is yarn.nodemanager.resource.memory MB. You can see that when I hover the mouse on this memory bar. So on each node we have 32 GB and we have given 24 GB memory, and this will be reflecting in the yarn_site.xml for that property. On top of this, you also need to understand the container related settings. Okay, so yarn runs on top of MapReduce, Spark, etc. So a container is yarn term, and depending upon the framework you are using, the terms used for the container can differ. If it is MapReduce, we talk about map task, reduce task directly for each container. If it is yarn, sorry, if it is Spark, we term it as executor. So these are the limits for the executor. So your executor can go maximum up to 4 GB memory. It cannot go more than 4 GB. However, as I have explained when I talk about the architecture, each executor has something called cache, and that is considered as overhead within each executor. So by default, 384 MB will be given. See here, Spark yarn executor memory overhead 384 MB is given to this. So 4 GB minus 384 MB can be the maximum amount of memory we can give for the executor. That's why I have given executor memory as 3600. And now I have given number of executors as 10. Within each executor, we can actually fork multiple tasks. And to increase the number of tasks within each executor, we can actually give executor cores as 2. So at any point in time, we will be using 3600 or 4 GB into 10, 40 GB memory from the cluster and 20 cores to process this data. Okay, it is very, very important to understand these three properties if you are using yarn to submit the job. Is it clear? If you guys have any questions here, let me know. It is very, very important to understand this. So I'm killing, I'm just following that. Okay, sorry. It again paused. I actually ran the job already. So I will show you once it comes back. This is very bad. I will post it on LinkedIn and Facebook so that those guys take it seriously. Still paused. Is it the case whoever is online? Is it frozen? Yeah. I think now it is back. Now it is running. Already 96 tasks are done. If you want to check the status, either you can go through the resource manager web interface. I just have to refresh this. Or we can also use the port number which we have used. Yeah, again stuck. Yeah, it's stuck again because I'm showing the resource manager. Okay. So I can click on this application master. That's what I was wondering because the internet speed is good. YouTube folks don't have any problem, but only WebEx is having issues. And yesterday the session itself is gone. I'm not able to start the session, and after that I even could not see in the history. I don't know what happened yesterday. I think they have a serious outage or something. Okay, now the job is almost done. You can actually click on these jobs. Yeah. Okay, still it is still executing. There seems to be some issue. Okay, let me see. Yeah, now I think it's progressing. Okay, reducers have failed. If you see, uh, it has executed 281 tasks, even though the total is supposed to be 272 itself, because the two tasks which were supposed to do the reduce by key, they were failing. Okay, as they were failing, it has retried 4 times, and then it has killed itself. So the reason why it has retried is the failure can be because of the bug in the code, because of the contention for the resources, or it could be because of the hardware failure also. To make sure that there are no hardware failures, it will actually retry 4 times. By default, we can control those parameters, but by default, it will retry 4 times. After fourth time also, if it is failing, then it will fail the entire job. So now the job is failed. To troubleshoot where the issue is, you can actually go here, click on this. I think we have to look at the, we have to click on this link and it will give the details about the, yeah, task commit denied. Okay. So there seem to be some memory issues or something. Let me see. I think many people might be running at this time, and I don't know why it failed. No, it doesn't matter. GW01 or GW02 should not matter. It is not issue of that, because the processing is happening on the cluster. There is issue on the cluster itself, due to which it has failed. Anyway, it has completed the execution. Let me see. It seems to be stuck again. Yeah, even though it has failed, you can actually in the end the job is successful itself. There are some failed tasks, but job itself is successful. Okay, it keep on retrying. So you can see here. Yeah. In the end, it is successful. I think it could not get resources for some time. That's why it retried, and after retrying several times, it actually got successful. And you can see the data here. Okay. So this is how the execution life cycle. So sorry, this is how the development life cycle works and how the job is submitted. And then you start at the job level. For each submission, there can be one or more jobs. In this case, there is only one job, and each job will be divided into tasks like this. Sorry, each job is divided into stages like this. And whenever there is an action, a new stage will be created, and you can look at the DAG to understand how it works. What happened? Okay, why DAG is not coming up? Anyway, let's see. And then you can see the each individual stage, and within each stage, it has used the same 10 executors to process the data. Okay, and if you need to get the environment details, you can actually click on environment and see the properties for the job that are in effect for your job. Excuse me. It is struck again. Yeah, now it came back. And then you can click on executors, and you can see the details about the executors as well. This concludes the development life cycle as well as execution life cycle. You can also run Spark submit and see other properties also. And you need to read these messages. It is very important. I realized after a very long time. Okay, some of the properties are relevant only to certain execution modes. For example, executor course is available only for standalone and yarn. Whereas if you are running in Mesos, you have to use something called total executor course. It is total course for all executors. Whereas for yarn, it's number of cores per executor. So you need to understand this also. Okay. On top of it, you also need to be familiar with yarn command. Yarn is a command line command where you can actually see the details about the jobs. So you can say yarn application list, which will give all the applications that are running at this time. So these are the applications that are running at this time through Hive Thrift server. I don't know who is running all these things. I need to troubleshoot these and kill these sessions later. Probably this could be the reason why some of the tasks started failing. Someone might be using many resources. Okay. So the yarn application list will give you the details about the applications that are running currently. If you want to get all, you can also say list all, and it will give all the applications that have ran so far. Okay, even all is giving only running ones. It is supposed to give all. I don't know. I have to check. There is a command for getting all the applications that are running at a given point in time. If you want to kill, what you can do is you can just say yarn application and hit enter. It will give the usage of the command and other options which it provides. So if you want to kill a particular application, you can kill the application, and then you can move your application to a different queue, so on and so forth. We have all these things. We can also get the applications based upon different app states. Okay, I think I need to give like this. So yarn application list app states all and hit enter. And this one will give the all the applications that have ran so far. So if you want to take care of uh, uh, any additional reporting at the application level, to send emails to you once the jobs are submitted or failed, etc. You can actually use these yarn commands, and you can actually get the necessary information and integrate with the mail servers and send the notifications to the operations team. Okay. Again, it got stuck. And now it is back. You can also, I think, get the details about the individual applications also. Oh, yeah, we can actually say help. Help give the usage itself. If you want to see the status of a given application, you can actually say status. So will the move queue option move the running application to a different queue? I think so, yes. It will move the current running application to a different queue. Okay. So that being said, someone have asked me about the videos related to different queues. I will definitely share probably today. If not today, I will share it on Monday. Okay. So that being said, now let us move on to the SQL. SQL is the foundation for uh, many tools within Hadoop ecosystem and even outside Hadoop ecosystem. So you need to be very proficient with SQL. Okay. And one of the ways to actually get started with SQL with respect to big data is Hive. Okay, Hive is the first tool which actually implemented the SQL interface, and even other tools like Impala or Presto or Spark SQL, all these things try to leverage on top of Hive. So learning Hive gives you a good start dealing with SQL type of interfaces within big data ecosystem. Just give me a moment, okay? So even though the course does not explicitly say Hive, it is very, very important to learn Hive, and I will cover few of the very important concepts with respect to Hive. Once you log in to the lab, you can say Hive and launch the Hive command line interface. Like Spark Shell, Hive is another alternative. Okay. And one more thing is when it comes to Hive, you cannot do much using your PC. It's better to log into the lab and practice Hive. Okay. And also when we start dealing with Spark SQL, there are limited options related to Hive. You need to again set up Hive and all those things. And also you need to make sure integrating your Spark installation with Hive to make sure those two things work together. And it is quite cumbersome. I do not recommend you to do it. Either you should use lab like this, or you have to set up Cloudera Quick Start VM or Hotworks Sandbox and try learning this stuff on those VMs or the lab. Don't try to set up Hive and try to integrate Spark with Hive, etc. on your PC. It is counterproductive as part of your learning process. That being said, once you launch Hive, you are in the Hive console, and you can run show databases to list the databases. There are many databases because it's a multi-tenant environment. All the users create many databases. For my purpose, I will be using a database called WLabs DZ DG and hit enter. So to switch to a database, you just have to use command. Okay. So show databases to list the databases, use and the database name to switch to a database. And if you are familiar with MySQL, Hive actually follow MySQL in many ways because MySQL is open source, and whatever these open source communities develop, they started with MySQL itself. So they inherit a lot of things from MySQL. But after MySQL is acquired by Oracle, some of the guys have actually switched to Postgres. Okay. So once you are into the database, you can run command called show tables and hit enter, and it will actually list the tables that are available in a given database. Okay. And then you have to create the tables. You have to insert data into the tables or load data into the tables, and you have to query from the tables. All these three things are important from the Spark perspective. You should know how to switch to the database you want to run. You should be able to know how to run the DDL commands to create the tables. You should know how to load the data into the tables. You should know how to run SQL queries. In which context you run, it's a different story. You can run in Hive itself, you can run in Impala, you can run in Presto, you can run in Spark SQL. Okay, all these commands which we are seeing now, we can run in multiple ways. Here you need to briefly understand the architecture of Hive. Okay, so Hive uses HDFS as file system. So if you create a Hive table, whatever data you try to load into the Hive table will be there in HDFS, period. If you are pointing to S3, it's a different story. You can create tables for S3 also. But typically it will be in HDFS or some other file system, whatever we have configured against our cluster. Okay. And then you have to, there will be a structure on top of it. Hive is nothing but data in HDFS, a structure on top of it, and then running queries using that structure. So when you create a table, structure will be defined. For example, let me come out of this. Okay. And let me actually see if there is data here. There is an orders table. Okay. Okay, the data is in euro format, so I don't want to use this. Let me do this. Hadoop fs -ls capital R user d ref orders. Okay, there is a table here, so let me use this. Hadoop fs -ls. Oh, even this one is euro. I need the non-euro files. Yeah, this is correct. I can use this one. So first, let me see the file format. Hadoop fs -tail and hit enter. So you can see data is comma separated, and data is already there in HDFS. So I can launch Hive. Either I can create a something called managed table or external table. I don't want to get into those details at this time. I will just show you simple create table example. Use wlabs dg. Okay, and then create. Yeah, I'll be covering file formats like Avro and JSON once I actually get into the data frames. So this is the foundation for data frames and Spark SQL, whatever I am covering now. So create table, orders, and let's name it as DG. Okay, so it has 4 fields. One is order ID, which is of type integer, and then order date. You can save it as string or date. I am saving it as string here, and then order customer ID, integer, and then order status string. Okay, once you have defined the table with the table name and the uh, and the fields like this, what you have to tell is the structure of the data, how it is actually stored in HDFS. Okay, so it is actually stored like this: row format, delimited, fields terminated by. Don't worry, you don't need to memorize this. I will actually review this against the Hive official documentation, and I will show you how to fetch this information, how to define the data types and all those things in a moment. But for now, let me finish this. So row format, so each row is formatted in such a way that they are delimited fields terminated by comma in this case. And then if I want to read data from this location, I can specify location here. And a location has to be, okay, it is stuck again. So let's wait for a moment. Yeah. Yeah, it is back. Okay, so now location is specified. And then we have to tell what format we are trying to store the data. And typically this row format delimited fields terminated by comes only with respect to uh, text file format. If it is any other file format like sequence file, arrow, etc., you don't need to specify this row format. Only for text file it is mandatory. Okay, and default is text file whether you mention it or not. If you want to mention, you can mention like this, stored as text file. Okay, there is some issue with the syntax. So let me. So now Bala is asking how to access the documentation. Yeah, that's what. You should not just search using Google like that. You have to understand the version which you are using. You have to get to that version of the documentation. 1.2.1 is the one which we are using. So you have to go to 1.2.1 documentation, and then you can click on this. So this is the official documentation which will be provided to you even as part of the certification if you want to do the certification. And you should use this for your reference. Okay. So here, okay, it is frozen again. No, it is not frozen. Yeah. So here you can see as part of the user documentation. If you click on user documentation here, you can see the DDL. You can click on this to get the syntax of the DDL. So all you need to understand about DDL is this simple create table command. That's what you. Someone is asking whether we can specify the size. You have to go through this and you have to explore that. Earlier versions you cannot. There was no data type such as varchar, char, etc. And we are not allowed to set any limits. But now they allow us to set, but it doesn't mean anything. They are just the informational purposes. Okay, so if you say varchar of 30, you can still store more than 30 characters because varchar of 30 is just informational for Hive. Hive will not enforce because Hive is schema on read, not schema on write. So the precisions are not enforced at all. It might be enforced if you run insert into command and if you try to load it using insert into command. Otherwise, it will not enforce. Okay. That being said, you can see the syntax here. I will not be able to get into all these details at this time. If you want, I can actually give the complete Hive related videos and you can go through them and you can understand. Okay, as of now, I have mentioned create. Okay, this is the problem with this Hive documentation. It is a bit inaccessible. I am zooming out a little bit here so that everything comes properly. It is stuck again. Okay, you can see here create table name, and you can give the column names. That's what I have done. And then you have to follow this order. So I specify row format. After row format, I have to specify the file format using stored as. Because I specified after location, it failed. So you need to understand the syntax, the order, and you have to follow this. Okay, whatever is there in the square brackets, they are not mandatory, but if you use them, you have to follow the order. And you have the subclauses for row format. This is another problem with this documentation. There are subclauses like row format, file format, etc. And you can actually scroll down a bit, and you can see the actual syntax for the row format, file format. So if you want to use row format, you have to say row format, and then you have to go here, and you have to see various options. Delimited is mandatory. After delimited, you can say fields terminated by, collection items terminated by, map keys terminated by, whatever is relevant to you. We can also tell how your lines are delimited. And also you can also tell how the nulls are represented. So these things are available as part of the Hive while defining the row format. So now if I go here, I have to say stored as text file if I want to specify. Even if I don't specify, it will work. But if I have to specify, I have to specify after row format. And the default is text file, but Hive supports sequence file, RC file, ORC, Parquet, Avro, etc. Okay, and then location, user, okay. Again struct Bigadraju orders demo. Meanwhile, I'm typing to complete the syntax. Oh man, this is way too much. And hit enter. Now the table is created. We can preview the data saying select star from orders. So in case of Oracle, we use row num, and in Hive we don't have row num. Okay, we can actually say select star from orders limit 10. It is similar to MySQL. MySQL also uses the same syntax to just display 10 records. Okay, if you want to 100, if you want to get 100, you can use 100, and then we can run the queries on top of it. Okay, thank you. The table name is incorrect. Orders PG limit 100, and you can see the records here. So how limit works internally, it will just fetch the first 100 records. That's it. It does not translate into MapReduce. It will actually go to the table and get the first 100 records if you don't have any other condition. If you have conditions, it will apply those conditions and it will fetch the first n number of records based upon the condition. Okay. So it depends upon how the query runs, and we will get into the internal details a bit later. Yeah, if it is SQL Server, it is like top 100. Yeah, very good question. Somali is asking whether we can run Hadoop commands. Yes, we can run. We can just DFS is alias for Hadoop FS. DFS is Hive alias for Hadoop FS. So if you want to run Hadoop FS commands, we just have to say DFS, and then you can actually do whatever you want. Let's say in this case, I want to look into that location, Bigadraju. What is the location? Orders demo. Hit enter. You can see the results. You can also say tail, cat, etc. Whatever you want to run. Okay. And now, if you want to copy data from to this, typically we use two commands to copy. One is load, and the other one is insert. The major difference between load and insert is load is primarily used to copy the files into Hive tables, whereas insert is primarily used to read that data from one table and write into another table. You need to understand this difference. It's very, very important. Okay, I will demonstrate and I will try to explain. So someone is asking what is this file? Whenever you run a MapReduce job, it will actually create this marker file. The size will be 0 to make sure that the job execution is completely done. After execution is completely done, after files are created, completely, the flow will end by creating this underscore success file. And it's just a marker file, and you can see size is 0. Okay, that concludes that a map reduce job is successful. Okay. Apart from that, it doesn't have any business significance. So now we will see how to load data into this table. So if you want to load from local file system, you can say load local, uh, load data, local in path. You can give the path. You don't need to create separate user, but I will highly recommend you to actually create a database with your username in Hive and use that database itself. Okay, so that you don't step onto the other stores. And then we have the orders data in this location, public orders, and then public retail underscore DB orders. So from this location, I want data to be loaded into my Hive table. So I can say into table orders underscore DG. Okay, load data because I am copying from the local path. So this is the local path. I have to say local. And then in path, we have to give the path into table orders DG and hit enter. Okay, there is no, yeah, it is actually data, not public. So this is the local path. It is stuck again. Path was incorrect, whatever I have given earlier. It is still stuck. Yeah, now it came back. This is way too much. Okay, so yeah, in path was for local file. So this is the local file path. We can actually see. I'm logging into another session. ls-ltr data retail underscore db underscore orders and hit enter. There is one file here. That one file will be copied. Okay. Now, if I want to look into that location, orders demo, after running the load command, now you see there is another file with this underscore copy underscore one because there is a conflict with this name and this name, which we are trying to copy. As there is a conflict, it has appended this. That's the behavior of the load command, and it have actually copied the file. You can also see the size. It is exactly same. So if you want to load files from local file system or HDFS file system into Hive table, which is nothing but another HDFS directory, you use load command. Okay, load data local in path is for copying from local file system. Load data in path is to move files from one HDFS location to other HDFS location. If you run on HDFS, it will actually delete files from the path which we are trying to move data, copy data from. The reason is, I think the rationale behind that is, if you just want to copy, not move, then you have to maintain 2 copies. Okay, if there is 1 terabyte data, the entire 1 terabyte data, it has to create another copy within HDFS, which can be very time consuming. If it is just have to move, it have to just maintain the file system table. It just have to change the metadata. It don't need to move the data from one location in HDFS to another location. It just have to change the metadata of tables, metadata of your data. That it is pointing to, it was pointing to some other location, and now it is pointing to new location. Whatever changes needs to be done, it needs to be done. I think that is the reason why they have implemented the behavior of moving the data from one HDFS location to another HDFS location. If you say load data in path. Okay. Now, if you want to copy this data into another table after processing, what you will do? Let's say I want to get the count by order status and copy into the new table. First, I will create a table. Create table order count by. It is stuck again, but I will be typing status. It takes two fields. One is date, and the second one is count by status. Okay, so I'm typing here order date. I'm defining the data type as string, and then order status, and I'm defining it as string itself. Sorry, order count. I'm defining it as integer. Okay, and now if I'm not going to specify the location. I'm not going to specify the delimiter. I'm only specifying stored as clause to save it in Avro format. Okay, and hit enter. That's it. So earlier I have mentioned that the data will be in HDFS, and I have proven that whenever we create the table, data will be in HDFS. Even after running the load command, data will be stored into HDFS. And then on top of it, we have actually ran this command called create table to represent the structure of the table. Actually, let me take the earlier example. Okay, this is the structure for our orders underscore DG table. Where this structure will go? This has to be stored somewhere. If you think about conventional RDBMSs like Oracle, it actually stores in something called data dictionary, which is nothing but bunch of tables within the database itself. So your data and metadata will be in the same database. Whereas here, your data will be in HDFS, but the structure will be in something called Hive Metastore, which is supported by a traditional RDBMS. It can be MySQL, it can be Oracle, it can be SQL Server, it can be any database. Okay, so this metadata will actually get into the RDBMS, which is called as Metastore. So your data is in HDFS, your metadata is in Metastore. Now, I will answer these questions in a moment, whatever you guys are asking. Now, if I want to copy data into this table, there is no data in the file system which match this criteria, order, date, and count. Hence, I cannot use load command. I have to use insert command. Insert into, again it got stuck, but I'm typing insert into table. Table name is order count by status. Okay, and then I have to give the query. Select order date, comma count of 1. Okay, I'm supposed to get order count by status, and let me actually fix the table name. Order count by date. I'm dropping the table, drop table, order count by status. And I will be creating table. With the name order count by date. Okay, rest of the stuff is same. Now I will be creating the insert. I'm using insert command. Insert into table order count by date. Select order date, comma count of 1. Order count from orders underscore DB group by order date. Okay, so I'm actually applying the transformations on the data, and the transformed data I'm loading into order count by date. What are all transformations I'm doing? I'm primarily doing performing the aggregation here. I'm actually doing reduce by key on the order date to get the count. Okay, so internally we are mapping the data. We are performing reduce by key or aggregate by key, whatever it is. If you think from the Spark perspective. Anyway, don't worry too much about it. I will relate these things a bit later. This is the sample insert command to select from one table and load into the other table. Okay. Now this order count by date will have data in arrow format for these results, order, date, and count. So let me take the questions here. Pramod is asking what is Avro. Avro is one of the file formats. It's kind of it's a binary version of JSON. Okay, it is one of the popular file format in big data, and Cloudera pushes about Avro quite a bit. And Dheeraj is asking, can we specify file name? No, you cannot specify file name. You don't have any control. Hive will take care of it. Okay, now the data is copied. I have mentioned that data will be in HDFS, but we haven't defined the location for this table. We just say create table, table name, or a couple of columns and stored as Avro. To get the information, you have to use command called describe. If you just say describe, order count by date, again it was struck. Yeah, and today the delay was a bit higher. Oh my god. No, it's not about the Wi-Fi. So my friend is saying the Wi-Fi is better, but it's not about Wi-Fi. It's WebEx issue. So describe and then the table name. You can see the field names. If you want to get the entire metadata, you can run a command called formatted. Okay, and you can see the metadata details, order date, order count, or the column names. This is the HDFS location. If you don't specify the location for the table, when you use create table command, it will actually uh, go into the warehouse directory, which is called as /apps/hive/warehouse. And for each database, there will be a directory under this warehouse directory with extension .db. And then for the table you try to create, there will be a directory by name of that table. And this is where your files will be. So you can actually run dfs-ls command on this location. And you can see the data. Most likely it is in the Avro format. You can actually say dfs-cat. There are a few questions. I will handle those things in a moment. Okay, and hit enter. You can see data is all convoluted because it is actually storing in Avro format. And we haven't specified the delimiter also when we create the table. And we should not specify delimiter except for text file. But if I run select star from order count by date, you can see the data. There are 364 rows, and for each day, it has actually given the number of orders. Okay, so that is how we can actually create tables, we can load the data, we can run queries, etc. Okay, this is a kind of Hive overview for Spark SQL. This is not Hive incomplete. So I have not covered many concepts that are important in Hive, and it's a bit fast also. If you want to learn Hive in detail, okay, you can go back to my previous playlists. Okay, I will give you the. I think I have the playlist for the Hive itself. itversity and Hive. You can search for that, and you can see here. There are few videos here. You can actually go through this to learn about Hive in a bit more detail. Okay, it will cover most of the important aspects. So let me take few questions here. We cannot specify file names. I already mentioned. Amog is asking, load data in path, overwrite into table that will keep file it as its location, right? No, that is not correct. That is not correct. Overwrite into table will actually overwrite your target directory with the new files. If you use load data in path and if you give HDFS directory, files will always be moved. And Somali is asking, can we do it in Impala shell? Very, very good question and very, very relevant question. Whatever I have shown here, if there is Impala setup, I don't have Impala setup on the cluster, but you can launch Impala shell and you can access these things. But we have Spark SQL here. So we can, similar to Impala, we can actually use Spark SQL, master yar, conf, spark.ui.port. Make sure you use these things so that you always get a session. And Spark SQL, you can access the same Hive metastore and run queries against it using Spark execution engine, using Spark SQL command line interface. Okay. Similarly, if you have Impala, you can use Impala also. Impala shell will run the same way as Hive. The output might be a bit different. We will see. We will see once the Spark SQL session is launched. Okay. Now you are in the Spark SQL session. You can run show databases. And it will list all the databases. You can use, you can switch to database saying use wlabs dg and hit enter. And then you can run show tables. You can see the list of tables here. It includes order underscore dg, which is just created, and also order count by date. You can also get the results by saying select star from order count by date limit 10. By date limit 10. And you can see the results. So you can run all the queries using Spark SQL or Impala shell, etc. But sometimes if you just create table uh, in a Hive session, and if you try to access from Spark SQL or Impala, you might not see the tables immediately. For that, you have to run a command called invalidate metadata or something. Let me check. There's a command. It is important to remember this. Hive invalidate investment metadata and refresh our counterparts. Yeah, that is the command. No, call me not missing. Validate metadata. Probably I think it worked in Impala. Probably in Spark SQL it might not work. I'm not 100% sure on this. But in Impala it works. I have done it earlier. Uh, it works for sure. I think Spark SQL it might not work. Okay, so there will be a way if you run those kind of issues. In Impala, it's quite common that if you create a Hive table, it might not reflect in the Impala shell immediately. If you run invalidate metadata, it will work. So there are a few more questions. Let me take these. So Somali is asking, creating table in Impala, will it be different from Hive? No. For whether it is Impala versus Tez versus Hive versus Presto versus Spark SQL versus any other engine, it uses a common file system and common meta store. The file system is HDFS and meta store is RDBMS database such as MySQL. Whenever you run create table command, all the metadata will be stored in the same Hive meta store. So the same statements execute in the same manner irrespective of the framework you are using. But when you run the queries such as select query on the data, Hive runs in MapReduce, Tez runs in Tez execution engine, Spark runs in Spark execution engine, Spark SQL runs in Spark execution engine, Impala runs in Impala execution engine. And when you run the query, there are multiple steps before the query actually executes. The first one is syntax checking, second one is semantics checking, third one is compiling, fourth one is execution. So syntax and semantics check is same across all the frameworks, but compiling and execution will change depending upon queries you run, and this will only change when you try to run select queries. If it is select or insert queries, if it is just a load command or a create table command, alter command, those things will work in same manner across all the areas. Okay. So the next question is, that is to answer Saumalya's question whether creating table in Impala will be different from Hive. Creating table will not be different. Even running queries will not be different, but the execution of the queries is different between different engines. So if you know SQL in big data, which is HiveQL, you can tell that you are comfortable with Hive, you are comfortable with Spark SQL, you are comfortable with many other things. So the next question from Sri is, if you are using partition, you are basically overwriting the partition. So if the word file is in another partition, that won't be touched. Partitioning is a different story. I don't want to get into details at this time. That is not very important for Spark. If you get into Hive itself, then you should know the partition. So I'm passing this question. The next question is from Ashish. Basic difference between Hive and Impala. Yeah, I have already explained it. Piyush have asked a follow-up question on that. Performance-wise, which is better? It all depends upon what you are trying to do. Most likely, using Spark or Impala is supposed to be better in performance than Hive in lower to medium-sized datasets. But very large datasets, Hive is a lot more efficient. Any MapReduce-based solution is a bit more efficient. Bala is asking, can I create a table on a directory that doesn't exist? It will create a directory if it doesn't exist. If you say create table command, it will create the directory as it have created for order count by date. Okay. Okay. Now we'll start getting into the data frame. This is just a primer on Hive. I haven't covered all the aspects of queries. We will see a bit of complex queries once we get in through Spark. And earlier I have shown you how to launch Spark SQL and run the SQL queries. But if you think about it, you will not be developing an application just in SQL. You need to have a programming language. So Spark SQL is only to explore the queries, or Hive is only to explore the queries. If you want to build an application, you have to fall back onto the programming language. In this case, we are talking about Scala, and for that purpose, you should be familiar about how to develop the programs using Spark SQL embedded as part of the Scala programs. For that, we have to go back and start developing using IntelliJ itself. For the exploration purpose, we should be familiar about how to write queries using Spark Shell. Okay, so here I am launching the session, Spark Shell, and we will see how to actually run these queries in Spark Shell. Ashish is saying, I read somewhere Impala is fast but don't know the reason. Is it because execution engine? Yes. So Hive uses MapReduce. MapReduce is IO intensive. Whereas Impala, Spark SQL, etc., they use different execution engine. So, as you guys know, Spark is more in memory than IO based. So between Hive and Spark, Spark is better when you try to deal with smaller to medium size, even larger data sets. But if you try to process very large data sets, uh, your cluster might not be able to put all the data in memory. Hence, you might start getting into out of memory issues if you try to use Spark SQL. As Hive uses MapReduce, and as it is not memory oriented, you will not run into out of memory issues. The job will be completed irrespective of the data size you try to process. Between Impala and Spark SQL, I don't think uh, one is faster than other. They both execute in the similar manner. But Spark is getting a lot more traction than Impala because Spark is not only for running queries, it can be used for different purposes also. Whereas Impala is primarily to run the queries, only for read-only purposes. You can actually write the data back using insert, etc. Apart from that, you can't do much. Whereas Spark give you a lot more agility because you can integrate Spark with programming languages like Scala and Python seamlessly, and you can actually embed SQL queries in that. That's why Spark is getting a lot of traction. But when you run a query between Spark SQL and Impala, I don't think those two are significantly different in the way they execute. Okay, these are out of the context questions about grid gain. I am not sure about grid gain. I never heard about it. And beeline, I will talk about beeline a bit later. Beeline is a bit out of context, but it is still relevant. So we'll take that question a bit later. First, let us focus on how to run Hive queries from Spark Shell itself. And then as we proceed, we will also see how to develop using the IntelliJ. Okay. So here, one thing you need to observe is when you launch Spark Shell, it creates the Spark context in the beginning. Okay, someone use the same port. No, two people try to use the same port which I am trying to use. I think you guys might be running in parallel with me. So that is why it has failed a couple of times, retried, and then it has given a new port. Anyway, that is not the main concern here. But when you actually see after running the Spark Shell command, the first thing it will do is it will create Spark context object. Somewhere it will be there. I'm trying to find. Yeah, here you can see Spark context available as SC. And in the end, towards the end, you also see SQL context available as SQL context. So you can get the details by typing SC. SC is of type org.apache.spark.spark context, and SQL context is of type Hive context. So by default, you will have this object using which you can run the Hive queries. Okay. So SQL context dot SQL is the command to run any Hive queries. Okay. So let's just review the data. Select star from order. Okay, we have to first switch the database. So either you can say SQL context.sql, use wlabs dg, in which I have created the tables, or I can also say select star from wlabs dg dot order count by date. Okay, and hit enter. It will run the query, and if you see, the output is of type data frame. It's not RDD. It's kind of a data frame. What is data frame and all, we will start seeing from the next class. Okay. So if you want to preview the data after running the SQL, you can run show. It will preview, it will get you the 20 rows from the data set. Okay. So this is how you can run Hive queries directly using Spark Shell. However, if you want to use IntelliJ, you have to define dependencies on build.spt. You have to import. You have to after creating the Spark context, you have to create SQL context pointing to Hive. Then only we'll be able to run the Hive queries. We will see that later. Okay, so here using this, you can do whatever you want. Let me create a new table. Saying create table order count by date other as select. So this is called a C task. Create table as select. Select star from order count by date and hit enter. You don't need to have so. Here I'm trying to run a bit more complex query. Okay, I have to give the database name. wlabs dv dot order count by date. Okay, now the query ran and the data is copied to this order count by date other, and you can actually say it got frozen. So meanwhile I will type. Okay, here when I create the table, I haven't given the database name. So I have to delete the database name. It's in the default database. Very good question. Okay. And then there is the additional bracket. I have to delete this and hit enter. And you can see the preview of the data. So this is how whatever you know in Hive, you can start implementing using Spark SQL or Spark Shell. So this is just a primer. We will actually start seeing a lot more complex examples starting from tomorrow, next class. So first we'll cover the data frame concepts. Then we will again come back to Spark SQL and we will see how more complex Spark SQL programs can be developed using IntelliJ. Okay, there are a few questions, very, very important and relevant questions here. As we are at the tag end, I will take any question now. So the first question is, which is still pending, is what about Beeline? So Beeline is kind of yeah, external service to connect to this database. It's if you are familiar with Oracle, there is a component called listener. So Beeline is like listener. So you that will handle your connection pooling and all those kinds of stuff. So if you want to write some programs using JDBC, I think you can use the Beeline. Okay, and whatever. No, I'm sorry. I'm sorry. Beeline is not for that. Beeline is primarily for the stuff like Spark SQL, which is not the client. For example, in this case, I am on my PC. I haven't connected to any lab. Okay. If I want to connect to the Spark SQL and run Spark SQL queries or Hive and run Hive queries, I have to go through Beeline. Otherwise, I will not be able to connect. So Beeline will actually establish the connection or will act as a proxy for any machine to be client to the cluster. Yeah, Beeline adds security. I'm not 100% sure about that, but that the main purpose of Beeline is to have a server or your PC as a proxy to access the cluster. So Bala is asking, using Spark context, I can also create an RDD for the same file. Yes, you can create this RDD for the same file using Spark context. That's the beauty of big data ecosystem tools. Your file system, your data which is in the files, and the execution engines are clearly separated. So you can process the data the way you want. Okay. Yes, Ashish, you don't need to you don't need to define the table schema. Where new table is created, I have already answered. Yeah, that is correct, Shakti. The table will be created in the default database. Can we use all the analytical functions, complex data types in Hive while using Spark context? Yes, we will be seeing that. We should be able to. And Praveen, I have asked a very good question: how to do select star from dual? Okay. So the way you can do is you just say select. Let's say current date. I think current date is the function. That's it. This is the syntax. There is no from dual. From clause is not mandatory in MySQL and MySQL derived databases. Hive is MySQL derived. So if you want to test a function, you just select and give the function name. That's it. And then how to choose one among RDD, data frame, and Spark SQL? Very, very good question, Srikanth. When it comes to structured data, if there is a Hive table, you go for Spark SQL. If it is structured data, but if you don't have Hive table, you can use data frame as long as it is structured and as long as you can implement your requirement in SQL, you can create a data frame. If you don't have structure on the data, you have to use RDD. RDD is low. Dealing with RDD is the lowest level which we can work on the data. Data frames and Spark SQL are a bit higher level, and they are wrappers which will hide the complexity of writing code using Scala or Python to provide the solution for a given problem statement. Okay, so instead of writing 20 lines of code in Scala, you might end up writing 4 lines of Scala code with 1 line with SQL query. Okay, very good question, Srikanth. We will see that in detail later also.
Can you please repeat that?
Yeah, we will see that, Amar. We will see those things in detail later, and this thing will be clarified for sure by the because if I explain now, as you don't know what is data frame, it doesn't make much sense to you. As I will be covering data frame, and after everything is done, the question will be automatically answered. And Dheeraj is asking, can we read a file and insert into tables? Can we read a file and no, that is not possible. If you want to read a file and insert into tables, first you have to create a table, load into the table, and then you have to read from the table and insert into other table. It's a two-step process. There is no one-step process where you can directly read the files and insert into table using Hive. With the Spark, you can do that. RDD can be saved into table. Okay, that we will see. I didn't get your question, Praveen V. How to do select star from dual in Spark SQL without Hive context? I don't know whether it is possible or not. And formally, I have already answered. There is no dual in Hive. You have to use like this. Select and the function name, and it will give the results. Shakti is saying all three we can work in Spark Shell. Yes, you can implement, you can validate RDDs in Spark Shell, you can validate data frames in Spark Shell, you can write Spark SQL in Spark Shell. Okay, so she is answering, asking a follow-up question. Why can't we use load in path? I think this is for the previous question. Can we read a file and insert into tables? I think she is asking why can't we use load in path? Load in path will only copy the files. It will not insert. You cannot perform any transformations on the data. Okay, so there is a difference between loading and inserting. Can we minimize the DAG while checking the logs? I do not understand your question, Somalia. And please change it to everyone when you ask questions. I didn't understand your question. Can we minimize the DAG while checking the logs? I think it is by default minimized. I think I got your question. So if you go here and click on jobs, click on this one. Yeah, DAG is minimized. If you want to expand, you can click on this. If you want to collapse, you just have to click on this triangle. Okay, you can. That's it. Okay. Any other question here? So this is just a primer. Whatever I have covered is just a primer. It takes a lot of time to learn Hive in detail, and we'll be seeing few of the pointers like analytical queries, where condition. So the typical transformations which we have done in core Spark, such as applying row-level transformations, uh, including filtering and aggregations and ranking. All those things I will be covering. But on top of it, you have to spend enough time to improve your Hive skills over a period of time. After programming language and Spark, Hive is the most important component in the big data ecosystem. Then comes Scoop and other things. So you have to be as knowledgeable as possible in the Hive. Yeah, I have already answered Somalia. I think now the issue might be resolved. Okay, she is asking what if the table loading 2 is a managed table, so we certainly can insert into a table by reading from a file. I didn't get you, Sri. If you can now unmute yourself and ask the question. You can always load into a table by reading from a file. But if you want to insert by applying certain transformations, that is not possible. It is only possible with the two-step process. First, you have to load into the stage table. Then you have to apply the transformation to copy the data into the final table. So there is no Spark SQL table. That you should understand that there is no Spark SQL table. There is a Hive table. Hive is the one which will actually maintain the tables. Spark SQL can read the data from Hive tables in a Spark context if you use Spark SQL. If you use Hive context and if you run HiveQL in Hive, it runs in MapReduce. If you use Impala, it runs in Impala context. So the question itself is not correct. Can we import data using Scoop in Spark SQL table? Because there is nothing like Spark SQL table. Okay, if you have Hive table, yes, you can import data into the Hive table. Yes, the data frame is better than RDD as per the documentation of Spark. There are few things which it is better in terms of development aspect, and it will cover some of the mistakes typically done by developers. But if you want to get the uh, uh, most optimal performance, RDD is the better way to go compared to Spark SQL or data frames. Okay, data frames and Spark SQL will take certain assumptions, will make certain assumptions, which are overlooked by developers at a time, at times. Hence, as part of the typical development process, using data frames or Spark SQL is better than RDD. But if you want to get the best performance, probably using RDD and processing as RDD after performing due diligence is can give you the better performance than anything else. So this is the last question. Ashish is asking, so it means we have to import first in Hive table, then use that table in Spark SQL. Is it correct? That is correct, Ashish. You got it right. There is another way also called Spark JDBC. You can actually connect to the remote database using JDBC, and you can query the data uh, through JDBC. What will happen is it will connect to the remote database and create a RDD out of it. The way you are connecting to Hive and getting the data from Hive tables, you can also connect to the remote databases using Spark JDBC and get data from remote tables into RDD. That is actually it will result into a data frame. So Srini is asking, can we load data into HBase once we process the data through Spark SQL? Loading is different. So whenever you want to load, there are multiple ways to load. You can actually create a Hive table also for HBase, and you can load through Hive also. So there are multiple ways to do that. To answer your question, yes, we should be able to do load data into HBase, but I will not be covering as part of the curriculum. We can load into MySQL, we can load into HBase, we can load into Cassandra, we can load into any other things. Okay. I think you are unmuted, Somalia. There seems to be, okay. Yeah, now you are unmuted. Yeah, what is your question?
Yes, actually my question is, while I was checking the logs, the image is there, right? That you are reading the table, then it will be coming one after the other. So it's coming as a huge image to my project. So I was not able to see it properly.
Okay, that's what you can
open this one.
you can click on this and minimize it, and also you can actually zoom out your browser so that yeah, this is the maximum zoom out I can get. So you can definitely zoom out and you can.
Screen is very slow.
No, I don't know how to fix your problem of reducing the image. One of the solutions is you can actually zoom in or zoom out. And this is one, if you can see this link, DAG visualization, if you click on that, it will minimize. If you can't see that, if it is popping up with the image, then the solution can be switch to a different browser, try to minimize it. You have to know how to do those things. Okay. Okay then. Thank you very much, and we'll catch up on Monday's session. See you, and have a nice weekend. Those who are on YouTube, thank you very much for joining the session. As you guys are aware, this is the backup for my live audience, so we might not be able to answer. We might have not able to answer all the questions. However, you can still raise the questions on discuss.itversity.com. We'll be glad to provide the answers. And also, if you like the content, please click on the like button. If you want to provide the feedback, you can wait until the video is streamed and you can provide the feedback as part of the comment section of the video. And if you need environment to practice, you can actually sign up to labs.itversity.com. The plans are very economical. And discuss.itversity.com is the URL for forums, for the support, in case you run into any questions while practicing. That being said, thank you very much and see you on Monday. Bye.